Example 5. A plane with airspeed of 192 miles per hour is headed on a bearing of 121 degrees. Okay, so again, keep in mind what bearing means. Bearing is a direction clockwise from north. And so they've drawn the picture for you. They started with the north-south line, and they drew a bearing of 121 degrees, and showed this plane's vector of 192 miles per hour. Okay. So, you can kind of imagine drawing this yourself if you had to. North-south line, bearing of 121 degrees, and you draw this arrow, this vector of 192 miles per hour. It's going to look something like that. Okay. Let's just use their picture because they can draw better than I can. A north wind is blowing from north to south. Okay, so this is something that might come up again. If they say a north wind, you need to know that it's blowing from the north. And so they're giving you a second vector, okay, a wind vector. And so they're saying a vector from the north. So we could draw it right here and make it look like the golf ball problem, okay, at 15.9 miles per hour. So, if we were drawing ours, we might have this. You might need to make it bigger so you can actually fit your numbers in there. But the question says find the ground speed of the and the actual bearing. So ground speed is always going to be the air plus the wind. Okay? It's talking about the result, okay? Not necessarily just adding those two numbers. I'm talking about vectors. So I'm saying the resultant vector of the airspeed and the wind speed. And so, this looks like the golf ball problem. I could have drawn it to look like the dog walker problem. Either way, you've got to recognize it's the same thing. It's the same result. And so the hard part becomes finding our angles inside of our triangle. Okay? So when we look at this picture, it's really difficult to see what we're going to do. However, you need a firm grasp of geometry. Okay? So notice this north-south line, and notice this north-south line right here. Okay? Those two lines are parallel. And we know a lot of things about parallel lines from geometry class 2 years ago, but we have to be able to remember. Okay? So notice the blue vector line. Okay? We have two parallel lines being cut by a transversal. Okay? So think way back to something we learned about in geometry class, and think about this angle inside of our triangle. Okay? You remember this angle, how it compares to this angle? They're equal. Okay? They're called alternate interior angles. Alternate interior angles are congruent. And so what that tells me is this angle must be 121 degrees. Okay? You've got to use some geometry skills. You've got to remember some geometry terms. But I get that because of alternate interior angles, that's 121. Okay? And so then if you think about it, you've got a triangle. You've got a triangle. And what does the temple runner see inside of this triangle? This looks like side angle side, right? Case 3, law of cosines. And so when we want to find the ground speed, that's going to be this side right here. That's x in the picture. Okay, so let me call it x. We're finding that length, and we should be able to use law of cosines to find that length. Okay? X squared is going to equal 192 squared plus 15.9 squared minus 2 times 192 times 15.9 cosine 121 degrees. So we're going to type all that in, okay? And let's see what happens. We're going to do 192 squared. And then square root that answer to get x by itself. 200.65, let's call that 201 miles per hour. X is about 201 miles per hour. That's the ground speed of the plane, okay? The speed of the plane plus the wind, okay? Notice the wind is at the back, okay? If the plane is flying this way and the wind is blowing in this direction, think about the wind as, is it helping it or hurting it, okay? The wind is helping it along just a little bit, okay? I know it's blowing it to the right, I guess, but it's pretty much pushing it. And so you're going to have a number that's greater than 192, I guess. Okay? If the wind was in the face of the plane, it would be a number that was less than the speed of the plane, 192. But in this case, the wind is helping a little bit. And so its ground speed is 201. So the second part of the question, they say, what is the bearing of the plane? Okay, the bearing of the plane. And so it's kind of hard to see in this picture, but the bearing is going to be clockwise from north, right here. And so it's going to be 121 plus whatever this little sliver is right there, theta. Okay? So we should be able to find this theta. Okay, theta is right here, right? And if you blow up the picture, it's a little bit easier to see. Let's establish that connection and let's use law of sines. We do sine theta over 15.9 equals sine 121 over, what did we just find, 201? And so let's multiply both sides by 15.9. Sine theta is 0.0678 or so. And do an inverse sine of that number, about 3.89. About 3.89. Let's just call that 4 degrees. Make it simple. Okay, let's just call that 4 degrees. And so this would be 4 degrees, or this piece would be 4 degrees. And so remember, bearing is clockwise from north. You're going to have that 4 plus the 121. 4 plus 121 is about 125. So the bearing is going to be about 125 degrees clockwise from north.